Good morning. So in the last class, we discussed 2010 and 11 paper, Unit 3, data representation. Today, we will continue our discussion on 2012 paper. Right? In 2012 paper, there are questions from 5 to 9. Right? Question number 5, 6, 7, 8, and 9. 5 questions. Right? So in 2012 paper, question number 5 is the binary equivalent of number 3a base 16 is. Right? So they ask you about the binary equivalent of the number 3a base 16. Right? So this is 2012 part 1. Question number 5. Right? So this is hexadecimal to binary conversion. Right? So you have to write the digit 3 separately, A separately. Before you perform the conversion, you have to get the decimal number equivalent of A. A will be 10 and this is 3. When you convert the hexadecimal number into a binary number, we have to make each and every digits in 4-digit binary format. So when I divide the number 10 by 2, it will be 5 0 2 1 1 0 0 1. Right? So A will be 1 0 1 0. When you have number 3, that is 1 1 0 1. Right? This is 1 1. If you want to make it in 4 digits, you can add 2 zeros in front. So your answer will be 0 0 1 1. When you combine these outputs, 1 1 1 0 1 0. Right? When you look at your answer options, all the answer options are in 6 digits, which means we can ignore the front 0 because there's no any value. So that's why your answer will be 111 010 base 2. Right? So 111 010, third answer option. Right? So that's the end of 2012 question number 5. Now 2012 paper question number 6. Right? So 2012 paper question number 6. In 2012 paper question number 6 is the decimal equivalent of the number 1010101 base 2. Right? So in 2012 part 1 6th question, they gave you the binary number and asked you to find out the decimal equivalent. Right? So the given binary number is 1010101 base 2. So what we are going to do is we are going to perform binary to decimal conversion. Right? When we try to perform a binary to decimal conversion, we have to multiply each and every digits by 2 to the powers from 0 to certain level. Right? So we have to make sure you have to put the powers from 2 to the power 0, 1, 2, 3, 4, 5, 6. Right? Actually, there is no necessary to write these things for the M.C.Q. But for the second part questions, I am providing the answers. Right? If you can perform the answers in a quicker manner or faster manner, you can do it. Right? In this case, there is no any value for the zeros. I can remove this one, and this one. Right? Why? When we multiply any number with 0, that will be 0. So 2 to the power 0 is 1, 1 into 1, 1. 2 to the power 2 is 4, 4 into 1, 4. 2 to the power 4 is 16, 16 into 1, 16. 2 to the power 6 is 64. So when you add these things, right? 64 plus 16, 80, 84, 85 will be your answer. Right? So there's an answer option, fourth answer option. You can determine the answer option is fourth one. Right? Now we will perform the next question, the question number 7. Right? We will consider the question number 7. Question number 7 is a very interesting question. Also, we discussed these type of questions in our class. Right? There's no any new questions. 2012 part 1 question number 7. Right? Question number 7. Consider the number 1 base x, where x is the base of the number system. Which of the following number system or systems can be the number 1 base x belongs to? Right? So they gave you a number which is 1 base x. So base x, right? So x denotes the base, right? They ask you which of the following number systems or systems can be the number 1 belongs to, right? So 1 belongs to which number system? So this is a question. When the base was not known, you can find the minimum base, not the maximum base, right? So the minimum base can be determined by performing the simple calculation, right? To find out the minimum base of the certain number, you have to find the minimum value in the certain number. Here, the 1 is the minimum. Right? As I said earlier in our class, for any number system, base will be greater than the maximum number digit that we use. For an example, when I have 15 as a number, in my number 5 is the largest unit, 1 is the smaller unit. So the base must be at least greater than 1 than the largest number. So largest number is 5. So minimum, the base must be 6 or greater than 6. 0 to 5, it's not possible. Why? So here the base will be at least greater than 1 of the largest number. So here, the largest value is 1. So when you are having largest value is 1, your base must be at least 2 or greater than 2. 2 greater than 2. So 2 means binary. 3, 4, 5, 6. There are base 3, base 4, base 5, base 6 numbers are there. But in our syllabus, we have 3. Base 2, base 8, base 16. Right? So your answer option is either binary, hexadecimal, or octal. Right? So we can put 2 here, or 8 here, or 16 here. Doesn't matter. So always remember this one. The base must be at least greater than 1 value than the greatest number or largest number in the given number. Right? So that is the theoretical thing for you. And the end of question number 7. Question number 8. Question number 8, we are going to consider B.Sc, binary coded decimal. Right? This is question number 8. Binary coded decimal B.Sc uses 4 bits to represent each digit in the decimal number system. Right? What is the bit pattern used to encode the decimal number 28 in B.C.D code? Right? So when we are going to perform the B.C.D conversion of the decimal number. Right? So we are going to perform the decimal to B.C.D conversion. Right? So decimal to B.C.D. When you are having a specific decimal number, the given decimal number is 28. Yes. What you have to do is separate the digits 2 and 8. Then convert each and every digits into 4 bits binary value. So 4-bit binary value is a must, right? So 8, when you convert it to binary, it will be 1000. So 1000. When you convert 2, it will be 10. So 0010. When you combine these things, 0010, 1000. When you are having a binary conversion, sorry, BCD conversion, you have to write the zeros in front to make sure it is in the 4 digits. It is must, right? It's must to have 4-digit conversion. When you are having only 2 digits, you have to add more zeros in front. So the answer will be 0010, 1000, 0010, 1000. Second answer option. Right? So that is the answer for the question number 8 of 2012 paper. Right? Question number 9. Question number 9 in 2012 paper. If 1 triple 0 triple 1 base 2, right? 1 triple 0 triple 1 base 2 represents capital G in ASCII, right? Represents capital G in ASCII. What character does ASCII 1000010 base 2 represents? Right? 1000010 base 2. Right? So they asked, what is this? In our previous class, I told you how to compare two binary numbers and determine which is the largest and which is the smallest. How to do that? We have to compare the digits from left to right. Right? Here it is 1, 1, 0, 0, 0, 0, 0, 0. But here it is 1, here it is 0. So this is the smallest number. Right? So what you can do is you can perform the subtraction to get the difference. So this is smaller one, this is the larger one, right? So I am going to subtract this one from this, right? So 1 triple 0 triple 1 will be subtracted with 1 double 0 double 0 1 0. 1 minus 0, it is 1, 1 minus 1, 0, 1 minus 1, 1, 0, 0, 0, 0. So your answer will be 1, 0, 1. Right? When you multiply it by 2 to the powers to determine the difference in decimal, this is 1, this is 0, this is 4. Right? So altogether it will be 5. So this letter will be less than 5 than this letter. Right? So we are having G. Right? So here you will have the alphabetical order. We have to subtract by 5. So 1 F, 2 E, 3 D, 4 C, 5 B. So your answer will be B. Right? So first finding out the difference. This is smaller one, this is larger one. So we have to subtract by 5 to determine the letter. So the answer will be B. Second answer option. Right? That is the end of 2012 part 1 MCQ questions, data representation. Right? Now we will move on to the 2012 part 2 questions. As I said earlier, the part 2 questions will be in your compulsory part. Question number 1, right? So in question number 1, part 2, there are 2 questions. Roman number 1 and Roman number 2, right? There are 2 questions you have to consider. I will do both, right? So we finished 2012 paper MCQ questions. Now we will continue our discussion on part 2. Right? So 2012 part 2, question number 1, part 1. The question is, convert the binary number 10101001 into hexadecimal. Show your computation. Right? 10101001. Right? So 10101001. So this is part 2 questions. So you have to perform the question steps in your answer sheet. Right? Show your computation. Right? So the computation must be represented in your answer sheet. So you have to write the computations in your answer sheet. So in this case, the question is, the binary number is given, you have to convert it to hexadecimal. Right? So the conversion is binary to hexadecimal. Base 2 will be converted into base 16. So 2 to the power 0, this is 2 to the power 4. Right? When you want to convert a decimal number, binary number into hexadecimal number, you have to write the binary number and divide the given binary number into 4 digits groups. So I have 2 groups. You have to multiply it by 2 to the power 0, 1, 2, 3. Right? So this is 1. I can remove this one, this one, this one, and this one. Why? We are multiplying it by 0. So straight away I will add 8. 2 into 1, 2. 2 to the power 3 is 8. So this is 10. This is 9. In hexadecimal number, 10 means A. This is 9. Right? So your answer will be A9 base 16. Right? So here for this computation, you will have 1 mark, and for this one, you will have 1 mark. Right? So that's the end of part 1. Right? Part 2 also came in data representation. So that one also we have to consider. Right? (2012) part 2, the number, second part question. Name a coding system used to represent at-sign 2A in computers. Right? We studied about the coding system, 5 coding system: BCD, EBCDIC, Unicode, and ASCII. BCD, ASCII, EBCDIC, Unicode. Right? So here they are asking about the coding system used to represent characters. Right? So when you want to represent characters, you can't use the which one? BCD. BCD is not belongs to the character representation. So you can use ASCII and Unicode. Here they ask only one. So the better one is Unicode. Also you can use ASCII and EBCD. So Unicode will be your answer. Also you can use EBCDIC and ASCII. Right? So ASCII also you can use. Right? For this answer, you will have 2 marks. So when you consider 2012 paper, the part 1 question, we have questions from 5 to 9. So 5 marks for the M.C.Q. Part 2 compulsory questions, we had 2 parts. So 2 into 2, 4. So altogether 9 marks. Right? So nearly each and every year, 10% of the marks will arise from this chapter. Right? So be sure about the subject. Right? So this module is very important one. So that's the end of 2012 paper. We will move on to the 2013 paper now. In 2013 paper, question number 4, question number 9, 10, 11, 12. Right? 4, 9, 10, 11, 12. 4, 9, 10, 11, 12. Right? So 2013 paper, I will discuss the M.C.Qs first. Part 1, the question number is 4. Right. A computer has a memory, RAM, capacity of 4 GB. Which of the following is equivalent to the RAM capacity of the computer? But so they ask you the conversion of 4 GB into bytes, kilobytes, megabytes, terabytes. Right? So when you are having these kind of conversion, you have to write the order. Right? Bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte. The given unit is in GB. So the GB is given. As I said earlier, from the smaller unit to larger unit, we will perform the division. Right? Larger unit to smaller unit, we will perform multiplication. Right? So here, when you consider the answer options, all are having the equal values, the units are different one. Right? From gigabyte to terabyte, there will be division. But here, 4096 terabytes. So the terabyte fourth option is eliminated. Then we have byte, kilobyte, megabyte. Byte, kilobyte, megabyte. Right? So this is answer option 1, this is 2, this is 3. So here, conversion from GB to MB is very simple. Why? Only one step conversion. So 4 GB. When you convert gigabyte to megabyte, you have to multiply it by 2 to the power 10. But how many GB? 4 GB. So 4 into 2 to the power 10 MB. 2 to the power 10 is equal to 1024. So 4 into 1024, it is 4096 MB. So always perform the simple calculation. This is third option. But gigabyte to kilobyte conversion is, megabyte conversion is simple one. So here 4096 MB. The answer is their third option. So that is done. So this is how you can save the time. Like otherwise it will be difficult. Right? The given digit is GB. You can convert it to terabyte, that is simple. Megabyte is simple. So terabyte is the wrong answer option. So I will convert megabyte. If fails, I will move to KB. If fails, I will move to bytes. Otherwise, no need of performing this one and this one. So your answer option will be third answer option. Like that's the end of 2013 paper, question number 4. Right? (2013) paper, question number 9. Question number 9 says, which of the following is equivalent to the decimal number 127 base 10? Right? So the given number is 127 base 10. Right? So 127 base 10. You can see they have provided 2 binary answers, 1 octal answer, and 1 hexadecimal answer. Right? So majority is 2 binary answers. So when you perform the binary conversion, sometimes you can get the answer, otherwise 2 answer options will be eliminated. So always do the majority answer based. Right? So the majority is base 2. So when I convert the 127 into binary, 127 into binary, you can see the binary value is this one. Or you can find out by dividing this one. 63 1, 31 1, 15 1, 7 1, 3 1, 1 1, 0 1 2 3 4 5 6 7. Right? So this is your answer. So when you consider the answer options, first one and second one, there is no any correct answer. So that's why based on this answer, I can eliminate 2 answer options. The first one and the second one. Now we have only 2 answers. When I perform one of these answers, I can get other answer is right or wrong. Right? Here 127 base 10. I can convert this one to octal or this one to octal. Why? This is 127 base 10, like the binary equal. So I can perform this conversion or this conversion. But for me, this is simple. If you are having this is simple, this method is simple, you can perform that one. I will perform this one. Right? So 1, this one. When you convert the octal equivalent, we will have how many groups? 3 groups. Right? So 3 groups, you have to multiply it by 2 to the power 1, 2, 1, 2. One plus 2 plus 4. 1 plus 2 plus 4. 2 to the power 1, 1, 1 into 1, 1. So your answer will be 1, 7, 7, base 8. Third option, 1, 7, 7, base 8. That is your answer option. Or otherwise, you can divide 127 by 8 and determine. Right? So here 15 times, the balance will be 7. 1 time, balance will be 7. 0, 1. 1, 7, 7, base 8. So you can perform this up and or this option. Right? Whatever it is, that is fine. So third answer option is right, which is 2013 part 1, question number 9. Right? Now we will perform the next question. We will consider next question. Question number 10. The binary equivalent of A9 base 16 is. Right? So the question number 10 is the hexadecimal to binary conversion. Right? Question number 10. Hexadecimal to binary conversion. When you consider hexadecimal number, the given hexadecimal number is A9 base 16. Right? So it is A9 base 16. Right? So A9 base 16, you have to separate the digits. Right? A9. A will be equal to 10 and it is 9. Right? So here you have to get the 4 digits binary number. Why? Hexadecimal is 16, binary is 2, 16 is 2 to the power 4, binary is 2 to the power 1. So we have to convert number 9 into 4 digits binary number. So it is 41201001. So 1001. When you convert 10 divided by 250 by 2 21 10 01. So number 10 will be 1010. But so here this is 1010 and this is 1001. Right? When we combine this one, 10101001 base 2. Right? So the answer option will be second answer option, right? So that's the end of 2013 paper, question number 10. Now we will consider 2013 paper, question number 11, the BCD question, right? So you can see each and every year, again and again, they are asking the BCD conversion, right? So BCD conversion, that is question number 11. Which is the smallest out of the following binary coded decimal representation? So you have to find the smallest BCD representation among the 4 answer options. The options are 0, 1, 1, 1, 0, 0, 1. Second one is 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, 0, 1. Right? So for this question, you have to try the shortest path to determine the answer. They ask you the smallest BCD representation, right? So here you must have a basic idea about BCD representation. So when we convert the decimal number into BCD representation, for an example 172, this one will be converted into 4 digits. This is 4 digits, this is 4 digits. So in this case, when I have 900 as another number, we have to consider the leftmost digit. Why? This is hundreds. This is 900, this is 100. Whether I have 99 here and 99 here, no issues. Why? This is ones, this is tens, this is hundreds. So you have to consider the leftmost digits, right? So here I will have it in the group. This one, first digit is 0. Here the first digit is 1. Here the first digit is 1. Here the first digit is 1. Right? So when we consider the first digit, as I said earlier, when you have 4 digits, when this digit is 1, whether these are 1, triple ones or zeros, doesn't matter. This is the largest one. Right? This is the smallest one. So likewise, here we are having 0, 1, 1, 1. Here 1, 1, 1 is there. So definitely this is greater than this one. This is also greater than this one. This is also greater than this one. So no need of converting this one. Straight away I will say the first answer option. Why? When your first digit is the smallest one, it will be the smallest one. Right? When you are not satisfying with the answer methodology, I will perform it manually. Here it is 1, 1, 1. So 1 plus 2 plus 4, it is 7. 1, 0, 0, 1. 8 plus 0 plus 0 plus 1. 8, 1, 9. So that is 79. Here 1, 0, 0, 0, 1. This is 8. So 8, 0. This is 80. This is 79. 1, 0, 0, 1. 8 plus 1, it is 9. 4 plus 1, it is 5. So it is 95. 1001, that is 9. 1001, that is 9. So the answer is 99. You can see this is the smaller one. Right? So when you're having the MCQ questions, there will be some techniques to follow. That's why I am telling again and again, do the paper class questions again and again as your homework. Right? Practice it again and again. Then you can find the shortest path to determine the answers. Right? So that's the end of 2013 part 1, question number 11. Now we will perform the 2013 part 1, question number 12. Right? So the question number 12. Again, ASCII representation, right? So here you can see each and every year they are having the ASCII question, BCD question again and again. Right? In 2013 paper, we have the ASCII question again, to ask question number 12. Right? So question number 12, this came from ASCII. Right? If the character small a is represented in ASCII as 11000001, 11000001, it is small a. Right? Then the character E would be represented. They ask you the E. Right? So that is your question. Right? So as I said earlier in our class, the relationship is small a to small z, there will be value increased by 1. Likewise, capital A to capital Z. Right? So here they gave you A and asked you to find out which one? E. So A, B, C, D, E. 1, 2, 3, 4. So plus 1, plus 1, plus 1, plus 1. So you have to add 4. Right? Here you have to add value 4 with A. Right? So from A to E, you have to add 4. You can do it in 2 ways. The method 1 says you can convert this binary into decimal, and then with that decimal value add 4, and then you can convert it to binary again. That is method 1, but it is a too long method. Don't do it. Right? Method 2 says convert the decimal number 4 into binary and add it to A. So A plus 4. So this is very simple question. So I will perform the method 2. So what I am going to do is I am going to add the decimal value 4 with this binary number. So in this case, 4 will be divided by 2, it is 2 0 1 0 0 1. So now I got the binary equivalent of the decimal number 4. I have to add with this one. So 1 0 0. 1 0 1 0 0 1 1 0 0 1 1. This is your answer. But as I said earlier, practice makes it possible, right? So you have to do it again and again. So the answer will be 1 1 0 0 1 0 1 1 1 0 0 1 0 1. The fourth answer option, right? That's the end of 2013 paper, part 1 questions in data representation. Right? Now we will perform. Okay, now I'll consider 2013 paper, part 2 questions. Right? So before I proceed that, if you are having any doubts up to now, you can ask. Otherwise, I will continue. Now we will consider 2013 paper, part 2 questions. Part 2 question. There are 2 questions came in the compulsory section. Part 5 and part 6 of question number 1. So part 2, question number 1, part 5. Right? Convert the binary number 101010 into decimal. Right? 10101010. It's a binary number. You are going to perform the decimal conversion. Right? When you are having a question in the second part, you have to write the answer steps. That is must, right? So the methods must be written. So here write the given question like this in your answer sheet and perform the calculations. So you can perform the computations by multiplying it by 2 to the powers. This is 3, this is 4, this is 5, this is 6, this is 7. I can remove this one, this one, this one, and this one. Why? Multiply it by 0. 2 to the power 1 is 2, 2 into 1, 2, plus 2 to the power 3 is 8, that is 8, plus 2 to the power 5, which is 32, 2 to the power 7, it's 1 to 8. Right? 1 to 8 plus 32, 160, 168, 170. So you have to say 170 base 10. Base 10 writing is not the compulsory. You can write straight away 170 as your answer. Right? So that's the end of 2012 second part, part 5 question. So in part 1, we had 5 questions, which is 5 marks. Part 2, this is 2 marks. Right? Now we will consider part 6 in the same paper, 2013 paper. In 2013 paper, there are 2 questions. One question is already done. And the next question is, write down the main purpose of an encoding scheme such as ASCII. Right? So what is the purpose of the encoding scheme such as ASCII? Right? So it's a simple question. They are asking this straightforward answer. You can see, to represent the letters or represent entire characters easily, we can use the encoding schemes such as ASCII. Why? In all the conversions, we can use the ASCII format. So straight away you can write the answer, write down. For the question, write down the main purpose of an encoding scheme such as ASCII. The answer will be, we can represent entire characters. We can represent entire characters in a standard format. In a standard format. By using encoding schemes. Encoding schemes like ASCII, EBCDIC, and Unicode. ASCII, EBCDIC, and Unicode. Right? So that's the end of 2013 paper. So 2 marks, totally 9 marks. Right? So average weight is 9 marks to 10. 9 to 10 you can get. Now I will consider 2014 paper, part 1 questions. Right? In 2014 paper, part 1 questions, the questions from 5 to 9, right? Question number 5, 6, 7, 8, and 9 are there. So the question number 5 I will consider. So 2014, question number 5. Which of the following is equivalent to the decimal value 131 base 10? Right? So the decimal value 131 base 10, they ask. The answer options are in, 2 answer options are in binary. 1 answer option is in hexadecimal, and the 1 answer option is in octal. Right? So binary 2 answers, 1 hexadecimal answer, and 1 octal answer. Right? So initially we had to perform the binary conversion, but there's also another consideration is there. Here, the given value is 131 base 10. So the conversion of hexadecimal and octal also very simple. But the majority is in binary. That's why I'm going to do it in binary conversion. So 131 base 10. So 131 divided by 2, that is 65 1, 32 1, 16 0, 8 0, 4 0 2 0 1 0 0 1. So your answer will be 1 5 zeros 1 1 base 2, right? So here 1 5 zeros 1 1 base 2, second answer option, right? This is what I am telling again and again. When you are having majority of base numbers of binary number, you have to perform the binary conversion initially. Then only you can determine the answer quickly. Otherwise, you can perform each and every one, but it's a waste of time, right? So the answer option will be second answer option, right? So that's the end of 2014 part 1, question number 5, right?